Section 9.1 is mathematical patterns. Our goal is to identify mathematical patterns found in a sequence. Use a formula to find the nth term of a sequence. On page 687, we have sometimes you can state a rule to describe a pattern. At other times, you have to do a bit of work to find a rule. If the numbers in a list follow a pattern, you may be able to relate each number in the list to its numerical position in the list with a rule. A sequence is an ordered list of numbers. Each number in a sequence is a term of a sequence. You can represent a term of a sequence by using a variable with a subscript number to indicate its position in the sequence. For example, a sub 5 is the fifth term in the sequence, a sub 1, a sub 2, a sub 3, a sub 4, and so on. The subscripts of sequence terms are often positive integers starting with 1. If so, you can generalize a term as a sub n, the nth term in the sequence. First term is a sub 1, second term is a sub 2, third term is a sub 3, the n minus 1th term is a sub n minus 1, the nth term is a sub n, and the n plus 1 term is a sub n plus 1. An explicit formula describes the nth term of a sequence using the number n. For example, in the sequence 2, 4, 6, 8, 10, the nth term is twice the value of n. You write this as a sub n equals 2n. The table shows how to find a sub n by substituting the values of n into the explicit formula. So over here we have the first term, a sub 1 is 2 times 1 or 2. The second term, a sub 2 is 2 times 2 or 4. The third term, a sub 3 is 2 times 3 or 6. And the fourth term, a sub 4 is 2 times 4 or 8. Example 1 says a sequence has an explicit formula, a sub n equals 3n minus 2. What are the first n terms of the sequence? It's helpful to start by looking at the first couple terms in the sequence. So a sub 1 would be 3 times 1 minus 2, which becomes 3 minus 2 or 1. A sub 2 is 3 times 2 minus 2, or 6 minus 2, which is 4. Following the same steps, for the remaining 7 terms, we have the third term will be 7, the fourth term is 10, the fifth term is 13, the sixth term is 16, seventh term is 19, eighth term is 22, ninth term is 25, and the 10th term is 28. Therefore, the first 10 terms are 1, 4, 7, 10, 13, 16, 19, 22, 25, and 28. You may have noticed a pattern as you look through the terms in the sequence. The work for this problem is written out on the next 2 slides. And now I would like you to try number 1. Find the first 6 terms of the sequence a sub n equals negative 5 times n plus 1.